So, grab your day 2 stuff. Now, most of this chapter is based off of day 1, which you guys all did very well. There's not one person who did not pass this quiz. And the second half is this day 2 stuff. Everything else, day 3 and day 4 sort of built off this. If you do well on day 1, day 2, you got the rest of this chapter mastered. Right? Day 4 is applications, day 3 sort of extension of day 1. All right, now before I do the notes for this, we're going to go back to what, grade 6, grade 7 kind of question, and I'm going to write out a nice little bed mass one up at the top here. So let's go up on the very top, let's write this out. 3, then 2 plus 4 in brackets like that. Let's write that down. Something you would have done a couple of years ago. Right? So, in math, we have a lot of operations, just hierarchies, right? You're supposed to do one thing before the other to get to the correct answer. So, on this question, what is the first thing you would do? The brackets, right? And you do the stuff inside the brackets, and you go, okay, let's take the stuff inside the brackets, put it together. What do we get? 6, thank you. Then we go 3 times 6, and we get our answer of 18. Pretty straightforward? Yay? Yeah? Okay, so now, that's bed mass. I'm hoping that you guys are all really good at it. But unfortunately, this doesn't work with polynomials, right? I'll explain why. So we have a similar question with polynomials. So going over here, we have this number outside the brackets. It wants times this bracket here. And our first step is to add the things inside the brackets. My question to you is, before we add the things inside the brackets, are they like terms? No. Can they be added? No. So we can't do our first step of bed mass. Right? So the goal of bed mass is to get rid of all these brackets, get the numbers and the terms out of the brackets, so later on we can start solving for that stuff. Right now they're trapped inside the brackets. Right? So we need another alternate path to do these calculations. And bed mass is just not working out because we can't combine the stuff inside the brackets. Right? So we need another way out. And so there is another strategy. So going back to our original question here. So we're going to do it a separate way, which you are not taught in the earlier grades, because there is no need to teach you in the earlier grades. But now we need a different technique to overcome the problem we just had. So we can't combine the stuff inside the brackets. Right? So we need to look at it slightly differently. This 3 that's sitting here, okay, it wants to multiply everything in the brackets. Okay, so that's what we're going to do. Instead of doing the adding first, we're going to say, hey, 3, you can multiply everything in the brackets. Right, so inside the brackets we have the 2 and the 4. So we go, hey, 3, you can multiply this. You go 3 times 2, what do we get? Yeah, 6. Then you go, hey, 3, you can multiply the second thing too. What do we get? 12. And we have 2 terms sitting here, so we should have a sign between the 2 terms. Should be a plus sign or a minus sign? Plus, because when we did that 12, it's a positive 12. Then we have a 6 plus 12, and we still get 18. Okay? So, using this technique, we don't have to do brackets first. This allows us to do math calculations with polynomials. Right? We're not breaking any math rules that you learned in the past. Right? We're just doing things in a different order. It still ends up with the same answer. We're not breaking the rules. It's going in a parallel path. So now this, what we call here, is called the distributive property. So that how do we spell it? Is DISTRIBUTIVE. T-R-I-B-U-T-I-V-E. I'll let you write that out. The distributive property. Jeez, pick some notes here. Right? Okay. The word distribute is to give, right? To spread out. So we take the number in front, we distribute it to everything over here. Right? That's what it means. Now this question, or something similar to this, showed up on your MSS assessment, and I think it was an unfair question. There was one question on your MSS that says, hey, use the distributive property to answer this question. There's one of those on there. And I talked to the people at MSS and said, hey, this is an unfair question, right? And they said, why? I'm like, well, our class is probably one of the furthest ahead in all math class. We haven't talked about this yet, right? And none of the math9 teachers have talked about it, but we talked about it now. Took the test a couple of weeks later, you would have seen it. And their rebuttal was, well, you see it in grade 8. Now, technically, it is mentioned very quickly in grade 8, but you don't spend too much time on it, right? So, and we usually do questions the other way. Ways to avoid this. But in grade 9, in grade 10, we use this a lot, right? So there was one question I thought was unfair, and you saw this on there, right? Called the distributive property, right? So now let's go into the technical definition of it, because the words get kind of confusing, right? Just so you're used to reading the language here, right? So we take the number outside of the brackets, the single one, and we multiply it to everything in the bracket. So we take this. If I had to name that, going back to unit 3, what's the name of that? Is it a variable? No. How many terms are there? The purple there. Monomial, right? One term, so it's monomial, right? So we take the monomial. All right? So we take this monomial and we multiply it to everything over here, to every term inside of there. And I used the generic phrase polynomial, right? Because if you had 2 terms, you call it binomial. If it's 3 terms, you call it trinomial, right? But so we don't know how many things there could be. Most of these questions have 2, 3 or 4 or 5. Process doesn't change. You take the monomial on the outside, you multiply it to every term inside, right? So let's practice this now. So that's the definition. That's interpreting it in math language. Let's do this. Okay, there's 2 techniques I'm going to show you. You can pick whatever technique works best for you. So I'm going to take this, and I'm going to highlight the different terms. I have a term here, and I have a term here. Notice I'm highlighting and including the sign, because the signs make a difference. Same with adding and subtracting. You have to take that sign with it. So I take this 2x, and I go, I'm going to multiply from the outside to the inside to this one here. And I'm going to go, okay, what's 2x times x? What do we get? Not just 2. What about the x's? This is a 1 here and a 1 here. We combine the x's together. What do we get? Sorry? Yeah. 2x squared. Okay. X times x is x squared. We add the exponents. The first term is done. Oh, wait for the notes, man. You're going to need this. Next one. Take the 2x on the outside and we multiply to the next term. 2x times 3. What do we get there? 6. What about the x? Just 6x. And since this is positive, we put the plus sign between it. Now, I like this method. It takes up less space, and once you get really good at it, it goes really quick. It's called like the rainbow method. If you do a whole page of questions, you create a bunch of rainbows everywhere. There is another method which you need to know. I said you can choose whatever method you want. You need to know the other method because questions sometimes show up like, what picture version does this represent? That kind of stuff. So the other method's called an area method. And I'll show you how that one works. And I like that one because it organizes the data much nicer. So off to the side here, we're going to draw ourselves a little T chart like this. Okay? Draw yourself the T chart, right? And you're going to take your polynomial, the long one, and you're going to write that on the top. So that's the x plus 3, right? You're going to write this on the top like this. And you're going to take your monomial, and you're going to write that one on the side like that. Okay? Jeez, what are you doing, bud? Come on. Right? Now, take your polynomial on the top, and we're going to split it into its terms. How many terms are there up here? 2. We're going to split it. So I'm going to draw a gray line separating it. Because I'm going to draw it here because that plus sign belongs to the 3, even though I did a bad job of drawing it out. Okay? And what we've created here is a little times table. What I like about this, it has boxes, and you fill in the boxes and you make sure you've done everything. Right? As long as all the boxes are done, filled in, you've completed the question. All right, so we go to figure out what goes in this box. You go 2x times x, and you put the answer there. Right? 2x times x, 2 times the number in front is 1, so we get a 2 there. X times x, x squared. The x and the x makes x squared. We add the exponents. Right? Then we go 2x times 3. And we got 2 times 3 is 6. This x has nothing to combine with, it's just 6. So I like this because it's much more visual. Right? You're less likely to make mistakes with the signs and everything involved. But it does take a bit more time. So you have to write it off to the side. Then when you have all the pieces, then you got to put the pieces together into an expression. 2x squared plus 6x, like that. Okay? Is this possible? Is that okay? All right? We'll do a couple more of these, get you guys used to it. Right? So I'm going to do both methods for the first few questions, but you can pick which one works for you, right? You need to be able to understand both ways, right? But you only have to do one way. So let's go over here. Let's do this one here. Okay. I'm going to draw my T chart like this. The long one goes on the top. The monomial goes on the side on a split at the terms. All right, so right before the sign here, I'm going to split it there. All right? And using the rainbow method, this is going to multiply this one, and it's going to multiply this one. Either way, all right, you pick the method that works best for you. So I'm going to do both of them at the exact same time. So the first empty box, we're doing the green arrow, negative 3x times 3x. We're doing this box here. They're the same thing. What do we put here? Multiply the coefficients together, combine the x's together.
Minus 9.
Negative 9, okay, that's good. What about the x's? X squared. Or if you're just doing arrows, you can just write that off to the side like that. Okay, then we do the next one. The purple times the blue, or we're doing this one here. So negative 3x times negative 6. What number do we get? Coefficient with coefficient. So negative 3 and 6, they'll combine to make what number? 18. Positive or negative? Positive. So plus 18 And the x has nothing to combine with, so it just stays the same. X.
You have to like write it as a positive?
Oh, you don't have to show the positive here, but when we show this all together, the terms need to be separated by a sign. So then you have to show the positive there. Okay? All right? Is that good? Is it making sense? All right? So you're going to use this a lot. All right? The distributive property. Let's have you try this one, the 4x one. All right? I'll write it off to the side as a t-chart. All right? Or you can do your arrows. See if you can come up with it. I'm glad that this walking around just what everybody had a good right on the first try. Right? The first multiplication should have been 8x squared. The second multiplication should be minus 4x. Now, sometimes what students tend to do is they go, okay, I want to combine these things together and they'll write down the answers 4x. These are unlike terms, so we just stop there. We can't add and subtract this anymore. That is our final answer. Okay. Another one. We'll do it together. If I have this monomial on the other side of the brackets, does it make any kind of difference in how we execute our multiplication? It doesn't. Right? You take the 1 and you multiply it to this. It just the arrows point the other way from the other side of the bracket. It's the same thing, right? So this C, right? And I personally like to do the inside one first, but it doesn't matter. You can do the outside ones first. Right? I go C times C. What do we get? C squared. Then I do the next one. I go C times this one. What do we get? 2C. Excellent, Cohen. And now we need a sign between here. Right? And we need, it's positive 2C, so we put a plus in. Okay. All right. I think you guys are getting this. I'm not going to have you guys do the assignment, but I want to give you a trickier situation. So go to the back. We're not going to do the back questions. I'm going to give you something new. All right. So underneath here, 5a squared b, like that, times negative 2a cubed plus 3b minus 4ab. I'll stop for you, Collins. Write that down. Huh? Yes, you're doing it now. You're doing this. I just have young children here and all the different things to say. Okay, so as you write it down, count how many terms are inside that bracket. How many terms are there? 3. How many multiplications are we going to have to do? 3. So make sure you don't miss anything. Right? 3 terms, 3 multiplications this time. If you prefer, you can write out the T-chart to help you out. That's more writing. I can see Cohen breaking already. Oh, we're almost done there, bud.
Yeah.
Okay? So, we take the outside one, and we multiply to the inside one. What do we get?
An answer.
What is the answer, Cohen LaFrost? Coefficient with coefficient, letters with letters. What do we get?
Negative 10 A5 B.
10 A5, B. Right? 5 with 2 makes negative 10. A with A, the 3 plus the 2 makes 5. And the B has nothing combined with, so it just stays the same. Okay. Then we take that 5 and we apply it to the next term. So the next term we got sitting here is this 3B. And I can take it and then go like this. And go, okay, coefficient with coefficient, letters with letters. Right? What do we have when we put it together? You got this now? What's the middle term now?
A2, B2.
A2, B2. What about the number?
15.
15. 15, A2, B2. Now we need a sign.
Plus.
Plus. Then we multiply to the third term. Okay. Coefficient with coefficient, letters with letters. Ryder, do you have this one? The very last multiplication. Negative 20. 5 times 4 is negative 20. Combining the A's. A 2 and a 1 makes 3. B2.
I did it.
Okay. Not too bad, right? That is
I could retire by now.
the difficulty of grade 9. But I want to push you guys further. Your assignment has a next level of question on it, which I haven't discussed yet. So as soon as you walk into grade 10 next year, polynomials is one of the first units you do. And you'll spend like,
Oh.
The hard stuff.
you'll do, depends on the teacher, this is one of the, you'll probably spend like a day reviewing grade 9 stuff here. Then you'll jump straight into doing more complex
Advanced
things.
calculus.
So,
Advanced calculus.
it's not that much more difficult, right? At least the beginning stages. So I don't want you freaking out. So let's do another one. One more, last one. Shh. All right, write this one down. 3A. 2A plus 4B. Okay, write that one down.
Oh, we're doing it not for
So I
one?
can fail and be with Wyatt.
Exactly.
All right. Yeah, write that one down.
I did.
Okay, so we have something that looks different than what we've been doing. What makes it different?
Oh, it's easy.
It's easy. Cohen, how do we execute this?
You like, okay, so you do like one,
Yeah,
not like one.
just show me.
It's
So
all
you do
like
like this and that, this, that.
Yeah.
You go this side, you go this, that.
You do this.
Yeah,
and
excellent.
This and
And
that.
you add them.
Yeah, and then you do this and that.
Yeah.
This, that, this, that. And then you do that.
Cohen should be a mime. He did an excellent job of demonstrating with his pencil what to do. So, if you're not sure what to do, we treat this as two separate questions. The plus is the last thing we do in bed mass. So we're going to take this outside one here, and we're going to multiply it to the inside here, and this one here. Then we take the outside one over here, and we multiply it to this one. And let's do purple. This one, right? So when we're done this calculation, how many multiplications have you done? Sorry? 4, right? So let's quickly do this. So the first one, the green arrow here, the 3a times the 2a. Now you can do this with t-charts as well. You just have to do 2 of those t-charts. That's all it is. The 3a times 2a, what do we get? The green one here. 6. 3 times 2 is 6. And what about the a's? A squared. We move on to the blue arrow. The 3a times the 4b. What do we get? 12. 3 times 4 is 12. Excellent. What about the letters? Huh? AB. And is it positive 12 or negative 12? positive. So we need a plus sign there. Then we move on to the next one. Allie, you should be participating here, bud. All right? And we go the gray arrow. And we do that multiplication. And what do we write down? 5 times 2 is 10. Okay, what about the letters? Now, there is nothing wrong with writing BA, right? But, this is what we were talking about math grammar. When we write letters, you should go alphabetical order. Because BA is the same thing as AB. You don't want these things to look different, right? So, this we'll rewrite as AB. And that needs to be separated here by a term sign, plus or a minus? Plus, because it's a positive. Then we do the final purple arrow. What do we get? What? Negative what, Savannah? 2 times.
Negative.
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 What do we get? Somebody. Cohen.
Negative 6b squared.
B squared. Okay. So it was harder because there were 2 brackets, but we are also not done. There is more simplifying you can do. Look at the expression you created. Are there any like terms that can be combined?
Yes.
Which ones?
12ab and 10ab.
So these two
That is a development.
can be combined.
Still pass.
So those two come together to make what?
22ab.
22AB. The other ones can't combine, so they just stay the same. So we connected last chapter with this chapter. And that's sort of like almost where you start running off in grade 10 with, right?
My brain is on fire.
Okay, we'll stop there.
Oh.